Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
All right, so people might notice that there is no 13th episode because...
13 is unlucky.
Yeah, that's why.
That's why.
And we did actually record an episode and it was awesome.
But the best one ever.
It was the best one ever, but it got lost because what happened? Linux went to sleep?
Audacity crashed for some reason, and then I couldn't recover from the audio files.
Right.
I got the original audio files, but there is like 1,000 of them in 6-second clips, and there is no way to determine the order. So
right.
Oh well, we could release 6 seconds of it, or just randomize the order.
That would be interesting. Yeah, there's all kinds of things we could do, but now we have two recording systems. We have this Zoom standalone recorder as a backup system, but
it's always good to have backups.
So always, yeah. How many times do we need to learn that lesson?
Yeah.
Always have backups. So, and this one for conferences could be really good for just putting in the middle and having it record people.
It's nice and portable.
Yes, super portable and wasn't too expensive, and it'll be our backup. So we wanted to talk about
polymorphism.
Yeah, because
you had a different framing for it.
Well, yeah, because my first exposure to polymorphism was learning C++, and I had to generate the C code because that's the way C++ compilers worked at the very beginning, or the compiler. There was only one of them. And it would generate C code, and you could look at the C code and figure out what was going on. And so from that, I slowly figured out how it was doing dynamic binding. And it was kind of like, well, why would it do this? And slowly from that kind of pieced together, over time, pieced together the motivation for doing this. But it was not what I would say. What I found was that people who had started with Smalltalk had this much deeper and better understanding of what polymorphism is and why you would use it. And I, coming from this kind of hardware background, was like, had to piece it together from the other end. And now we've got these other ways of thinking. And we talk about ad hoc polymorphism, which isn't dynamic binding. And then there's type classes, which is that ad hoc polymorphism?
I think it's related to ad hoc polymorphism.
Okay. And then and then we were discussing extension methods and
row polymorphism.
Row polymorphism, which is structural typing, which is
kind of like duck typing.
Yeah. And it's what you get with, say, C++ templates, and you get it with, with Python and Ruby. They treat things as long as I can call these functions, I don't really care what type it is. So as long as it has like the shape that they're interested in, they don't care what the rest of the shape of the object looks like.
Yeah.
And it's like all these things. And I guess my insight was, well, we create these types and there's overlap between one type and another. And we're trying to make use of that overlap so that we don't write extra code. So
avoid copy and paste polymorphism.
Is that a kind of polymorphism? I mean, maybe it is. That's the thing. I'm all confused now on what the term polymorphism means. It means many faces, and we use it to mean multiple implementations with the same interface, or at least that's the way we've talked about it.
The word polymorphism doesn't that come from category theory's morphism?
I don't really know anything about category theory, so.
But yeah, I think thinking of it as overlap is the right kind of meta concept for what we're really trying to do, is make it easier to deal with the overlap that we have in functionality across different pieces of our code or classes or types.
Yeah, because we could think of it in terms of reusing code, or we can also think of it in terms of writing less code.
Right.
So if I can say, oh, these things are in common. I can write this one piece of code that works with more stuff.
That's right. There's overlapping need or overlapping functionality.
Mm-hmm.
And how do we not
How do we
copy and
make use of that?
how do we make use of that? How do we avoid copying and pasting that across different classes or whatever it might be?
Yeah.
Yeah, and so the first place, like you, that I experienced polymorphism was just through inheritance, and I think that's where probably most programmers have dealt with polymorphism. But then the second type of polymorphism was through generics in Java, and the technical term for that, for how it's polymorphic, is called parametric polymorphism, and that's saying that you use the type parameters to be the way that you deal with that overlap. But then more recently, I've been doing a lot more ad hoc polymorphism, and so I think that I haven't until recently started to kind of think more deeply about why there are different types of polymorphism and when you should use each type of polymorphism. So a little bit on ad hoc polymorphism. The what we ran into with subtyping based polymorphism was that you had to extend the type to be able to have the polymorphism, right? You have to use the inheritance mechanism to add functionality, to take advantage of the overlap, the reuse
To
from
override. Yeah, you had to. Yeah, and then we were talking this morning about oh, there's this difference between you have your whole interface defined in your base class and you never extend it, and then in C++ and Java and things, well, one of the things you could do is extend the interface in the derived class. You can't use it in the base class, but now you have an object that does more stuff based on what it already does. And then we were observing that with extension functions, there's probably no reason to ever do that. So your base type just is never, I mean, if you need to add more functions, you use extension functions. You would never put them on during inheritance.
Yeah. Well, and so I think one of the issues that we ran into with the inheritance-based polymorphism was that there were places where you couldn't change the base traits that you needed the functionality on. And because of that, you had to do all sorts of weird things to get around the type hierarchy and not being able to like add overlap into somewhere in that hierarchy that you don't control.
I mean, isn't that, you could think of cross-cutting as maybe that same kind of attempt.
Yeah, I guess maybe AOP did allow some of this, with adding functionality across the type hierarchy. And so ad hoc polymorphism, it allows us to add that functionality at anywhere in the hierarchy, anywhere at any type we can add functionality to something through an extension method. And so that's, I think, why it's termed ad hoc, is that it's not based on inheritance.
So you're saying extension methods are also ad hoc polymorphism?
I think they're part of ad hoc polymorphism. I think that they give us in part what we need from the limitations of subtype based polymorphism. They allow us to work around some of the limitations, but and I now with we were talking earlier about how extension functions have made so many things so much more ergonomically better and made so many use cases easier. So the use case that you brought up was that in Kotlin, when you add extension functions to, let's say, the list class in Java, you now have new functionality available to you on list, but you didn't have to extend the list type. And
You don't have to break the compatibility
That's
of
right.
the list type, and you get this
It's still
thing
just
which
a
is
list.
just amazing. I mean, there's all this functional stuff and everything that you're able to do with it, but then when you're done, you can just hand it back to Java if you want to.
Yeah, exactly.
Seamlessly,
It's
because
just a list.
yeah, it's still that, and all of the optimizations and everything that were done for the lists in Java, you get those,
And everything that extends list, because you still are taking advantage of subtype based polymorphism, where now if you are doing this on a type that has many layers of extension, you still get that on all the layers that are extending from that thing.
Yeah, the extension function, it just, when I first saw it, I just thought, oh, this is just a little bit of syntactic sugar. It's nice, but is it that big of a deal? And then as time has passed, I've realized, yes, it is, and I can't figure out why.
Yeah, it just feels good for a lot of things.
It does.
Yeah.
And it's so, I don't know, writing extension functions seems very straightforward to me. I'm not thinking about all of the stuff. I'm just going, I want to do this one thing. I can add this extension, then I can use the extension wherever I want to, and I'm not burdened mentally with the whole type hierarchy.
Yeah. So when you and Scala 3 is now getting extension functions as well. So this is becoming just kind of a new polymorphic norm.
And do we know, because my impression was that extension functions were created for C# and like Anders invented them or something. That was my impression, but I could be wrong.
I'm not sure of the history of it.
Yeah. But they're becoming more expected.
So I think in the history of polymorphism, we did subtype based polymorphism, and then we added in parametric polymorphism, and now we see most languages starting to add ad hoc polymorphism as well. So there's another piece to ad hoc polymorphism that I think is if you use extension functions long enough, you get to the point where your extension functions sometimes need some context when you use them. So if you're building a JSON parser and you have an extension function to parse some object into parse some object, that thing needs to know how to parse like a string and a boolean and an int as well. And you don't want to have to always be passing that context or the things that thing might need to it explicitly. And so the in the world of Scala and probably Haskell and some languages that have had ad hoc polymorphism in various ways, is you get to what we call type classes, and then there's some other names for it too. Rust has type classes, and what this does, it allows you to say, all right, here is a function, and here's some context that it needs. And so you say, when you define your function, and this could be an extension function, is here's the context that I need. And then the compiler goes looking to try to find something that can fill in that context for you.
So it's all statically determined
at compile time.
Is that a definition of type classes that it's always static?
I guess I've only ever seen it done at compile time. But yeah, I don't know.
And because the compiler is the one that goes and finds this, right? I'm just trying to imagine, could I do this in Python, for example? Could I simulate
type classes,
but then what's the lookup mechanism?
Yeah.
It's got to be dynamic.
Right. Yeah. So then it would happen at runtime. So maybe you could do something like type classes in Python. But it would be a runtime. It would have to be at runtime. So.
And how similar or different would that be from dependency injection?
So I think there is some overlapping functionality between type classes and dependency injection, because what you're saying is I need this thing, and I don't usually want to have to explicitly tell you where to get that from. I want you to go find it. And dependency injection typically is that you're constructing objects, and it's, I guess maybe one of the differences is that dependency injection is focused on usually on object construction, and not on method, on running a function and the necessary requirements to run a function, or the necessary context to run a function. But in dependency injection, it's like, okay, I want to create an object that is um, that is let's say a user service, and my user service needs a database service, and it needs a login service, and it has these dependencies, so it has this context that it needs. And when you use dependency injection, what you do is you go to the dependency injection controller, the context as it's called in Spring, and you say, all right, assemble me a user service. So you never call new user service. Instead, you go to the context and say, I need a user service. And then the dependency injection context, it knows how to figure out how to assemble the hierarchy of things that are needed so that it can get you back a user service.
I gotta say, this sounds like a builder.
Yeah, I mean, yeah, I think the difference is that typically dependency injection is using some configuration that tells it where to get those things from. Or so in Spring, most recently, it's annotation based, is what's telling it about the hierarchy of things and where to get them. But before that, initially in Spring, it was XML based. So in XML, you would say, here's the objects that can be injected, and the dependency injected, and the things that they need. And so at runtime, what Spring is doing is it's building this information graph about the beans that can be dependency injection. And then when you say, give me a user service, it then knows it needs to go create the database service, and the database service needs some configuration to know what database to connect to.
So it sounds dynamic.
It is in most of the dependency injection that I've dealt with, it is dynamic. But it's, yeah, I think it is dynamic, but oftentimes it doesn't really. You're being kind of hierarchy, your being graph doesn't actually change at runtime, but it does get assembled at runtime.
But isn't Micronaut, aren't they doing their stuff more compile time?
Yeah,
oriented?
so Micronaut, and I think Quarkus maybe too, is still doing dependency injection, but it's somehow is doing it at compile time. So it's like resolving the graph, the dependency graph at compile time. And I don't know how they do that. I know they use the Kotlin annotation processor, but they're doing some magic to make all that work. But so ultimately for me, dependency injection is that you've got this graph that defines the requirements at each node in the graph. And so somewhere that graph is known, and at any point you can say, I need this thing, and it knows how to give you one of those things, create one of those things for you, and fill in all the required pieces underneath it.
So the way this is coming across to me is we've got some common code, and then we have all of these pieces that can vary. And dependency injection, at least, is one way of saying, okay, well, we'll take the varying pieces and we'll assemble them so that you're not like duplicating everything in this place of common code. So we're separating things that change from things that stay the same. And it seems like that's very similar or maybe identical to what type classes are doing. I mean, each of the type classes are, okay, this is a very distinct, different way of doing things. And then you've got this common code that chooses which type class to use.
Yeah.
So how are they different?
I think the way that type classes are usually used is not for object creation, but is for function parameters. And I think that there is an underlying commonality to what dependency injection and type classes are doing, It's just that dependency injection is usually used for construction, and object construction, and type classes are usually used for function parameters. But yeah, I think
But I could use dependency injection for object construction instead. I mean, sorry, I could use type classes for object construction instead of dependency injection, couldn't I? I mean, just the
Yeah,
construction
yeah,
function would just use
yeah,
type classes.
yeah, yeah. I'm trying to think if that's ever
So
really
maybe dependency
done, but
injection is just a special case.
yeah, and I think that one of the kind of hallmarks of dependency injection is that the graph is in some ways determined at startup time or runtime, whereas with type classes, one of the, I think the core tenets of it is that the graph is determined by the compiler. And maybe you could do something that looks like type classes differently, but and maybe this gets a little bit blurry because I think Micronaut is kind of doing the graph generation at compile time now, and so
And that was for efficiency, if I remember correctly. They were saying it's taking too long. So,
startup time,
yeah.
yeah, is a lot better when you can do it at compile time. And then also for GraalVM, because remember GraalVM doesn't really like reflection.
Mm-hmm.
And so Micronaut knew they wanted to support GraalVM, and so I think that was another reason they tried to do this at compile time, was that then you don't have to use reflection, because Spring has always been based on reflection. I think that for GraalVM they're also trying to make some changes to how they do that. I'm not sure how they're doing it, but it was always based on reflection. It's like, okay, how do I when I need to create this object, how do I do it? Oh, I use reflection to create that object. And then they also used reflection for other pieces as well, but it was all reflection based.
So with dependency injection, it sounds like the use case is we want to have this configuration file where we determine the characteristics of our system. And we want to be able to change that easily and not have to recompile our code.
I'm not sure about the recompile thing, but where I think yes, you could maybe do that. Well, actually, with XML based dependency injection configuration, absolutely you could do it without recompiling your code, because it's just a config file that gets read. But where this most often got used and was really useful was that you would often want to change your dependency graph based on whether you're running the application or running your tests. And so when you're running your tests, you want to say, okay, I don't want to actually use my database service, because I don't want to talk to an actual database in a unit test. Instead, I want to use a mock for that service, and I'm going to use a mocking framework or manually mock that database service class. And so when I run my unit test, I'm instead going to tell it that the graph that I want it to use is not going to use the real live database service, but instead use my mock database service. And so that's where you most often changed the structure of your dependency graph, was for test versus run. And it turned out that was super helpful and useful to be able to change those things so easily.
But is that worth the cost of all the dependency injection stuff? Or if that's our predominant use case, maybe we should have a special design for that rather than generalizing it to dependency injection.
The nice thing about it was that you can change any part of your graph. So these graphs can be like massively complicated in terms of how interrelated there are. They deal with circular dependencies, which can very easily happen in dependency injection. They deal with a typical example that I have to override my graph is for JSON configuration. So somewhere deep in the HTTP processing layers of Spring, it needs to read some configuration for how to do like JSON parsing. Like, is it going to allow is it going to allow dashes in names for JSON properties or something like that? I don't know. But there's been many times where I've had to change how my JSON processing works, which is deep, deep, deep in, I've got Spring Framework, I've got my controllers, I've got my HTTP handlers, I've got my body parsers. Like if you looked at the graph for HTTP handling, like you're probably talking about 200 different beans that are involved in just HTTP handling. And so I want to change one of those things. And all I do is I say, all right, here is my override of the JSON configuration bean. And I can change that. I can change that globally. I can change that for kind of specific places. I can change that based on, if I wanted to, for some reason, change it in my tests. So I can define essentially at runtime that I want to override that thing that is deep down underneath the covers of HTTP handling. And so that's actually really nice, because you think about the alternative, like if we were going to do this with inheritance-based polymorphism, I would have to touch 100 classes, like override. I'd have to
You recompile everything.
I mean, there would be so many places where I would have to create a new instance. Mm-hmm. And then I'm sure there's going to be some place where something is final and I'm not going to be able to actually do what I need to do. So dependency injection is really necessary for being able to mutate the graph of dependencies and how they're wired together.
So it almost sounds like more geared towards operations, because it's like, we need to, I don't know, shard across more systems or whatever. So we go and we change this configuration file and we don't have to change all the code, and it redoes
I think there is an element to that. So configuration is definitely a place where dependency injection allows you to easily make changes and not have to recompile or not modify the structure of that graph. So yeah, I think there is that element, but even aside from operations, like I needed the JSON parser in that use case to work differently for my application to work as I needed it to. Mm-hmm. And so it wasn't just about the operations. It was actually, I was modifying behavior of something deep in HTTP processing land. Mm. So there is definitely a lot of similarity to type classes, because I can do the same thing with type classes. It's just that I resolve that graph at compile time instead of at runtime.
Right. Yeah.
So there's another form of dependency injection like stuff that for me helped me understand a bit better about some of the problems that we were trying to solve with dependency injection. And it was called, I encountered it in the world of Scala. It was called the cake pattern. And
cake. I thought you said kick.
Kick. The cake pattern. So in the cake pattern, what you would do is you would have layers of dependencies, and at your endpoints, which I'll describe in a second, but at your endpoints is where you would assemble your cake of all the layers that were needed of dependencies. So back to like the user service example, is my user service needs a database service. The database service needs a configuration service. Let's just keep it with that for now. And so when I have my actual web service application that is going to use the user service, when I go to create a user service, I need to tell it, here's your database service and here's your configuration service. So I have to give it all the layers of the cake when I go to assemble that. And then in my unit test, I again have to assemble my layers of dependencies when I go to create my user service. And that's where I can then change out the database service for a mock database service or something like that. So it became an explicit compile time way to do essentially dependency injection. It's like,
Oh,
here's all the things that are needed. Here's all the things, the dependencies that are needed to create a given thing.
but instead we're putting them together as layers of the cake rather
Yeah.
than using the dependency injection mechanism. And
Yeah.
yeah.
So the cake pattern was interesting, but it had some significant flaws.
Which were?
I think one of the biggest ones was just painful to always have to, because these graphs get really complex, and so it became unwieldy to have to always be assembling these cakes, manually putting together the dependencies that are needed for everything. And so Zio, the Scala framework that's kind of like dependency injection, it allows you to kind of do something similar to the cake pattern, but the ergonomics of how you assemble the cake are vastly better than the old cake pattern. So you still do have to assemble the dependencies that are needed, but there's something called a Z layer, which makes it much easier to assemble the pieces and reuse those layers across different pieces. So, but it still happens at compile time, and compile time verified. But the interesting thing about Zio is that you still, when you're at the end point, when you're at the thing where you actually want to assemble a graph of stuff so that you can use it, you do have to put together all of your dependencies that are needed there, and tell Zio, here are my dependencies. And so and then you can do that differently based on when you run your application, like in your web service, versus when you test your application. So you can assemble different Z layers, or they call them environments.
So is that the object that gets passed from function to function? The Is that the thing that you can say, oh, I want to add another layer to this?
Yeah, so in Zio you can manipulate your environment at kind of each operation that you do within
Mm-hmm.
a Zio. You can manipulate your environment and add something to it, pass it to the next thing.
Hmm.
Um, so
That's mutability, right?
no, it's all done immutably, which is one of the wonderful things about Zio is that you're
Because
doing
when
all.
you say manipulate the environment, it sounds like changing the environment.
It is, but it's doing it in a copy.
Oh, right. Okay.
Yeah,
Of course.
yeah.
Of course, that's how you do it. So yeah, that's interesting because I remember when the cake pattern was like,
All the rage in
yeah, all the
Scala.
rage, and everybody was, oh, just use the cake pattern here and there. And, the meta question is always, is this a real thing or is this going to fade away? Are we going to discover, oh, this doesn't really work? There's so many things that have happened that way in the
Yeah.
past.
Well, the Scala community is very, very smart and does a lot of experiments, and they learn from those experiments. And I would say that Zio actually learned a lot from the cake pattern, and they've made the ergonomics so much better. But there is some conceptual overlap between the cake pattern and what Zio is doing.
I mean, I find that helpful to say, oh, look, we tried to solve the problem this way and it didn't work out for these reasons. And so that's why one of the reasons why we're doing it this way.
Yeah, yeah,
And it's so different. I mean, the two approaches seem so different to me. The cake patterns were assembling these layers of things, and then Zio were passing this object from function to function.
yeah,
And it's, how do you think of that stuff? How do you
yeah.
math? Maybe, I don't know.
Yeah, John DeGoes and a number of other people, they had some insights for sure, but those insights were based on prior experience and prior challenges that they had, and then uh, a while back, a lot of the Scala stuff that was happening was motivated. A lot of the interesting Scala stuff that was happening was motivated by Haskell folks, and there was sometimes a mismatch between trying to bring something from the Haskell world into Scala just didn't quite feel right. Like there was problems with in pre-Zio stuff, there's problems with type inference, and I don't know all the details. We need to get John DeGoes on sometime, but there was problems with type inference in how they had brought some of these Haskell things over to Scala. And one of the amazing things that Zio did was it made the type inference so it worked. And so you didn't have to deal with type challenges in Zio like you did in some of the predecessors to Zio. And so
Has it influenced the Scala 3 design at all, do you think?
I think so. Okay. Yeah. And I know that a lot of the Zio folks have been working with the Scala engineers, and Scala 3 and Zio, I think, is going to be a pretty amazing combination. But so back to type classes, I think that in a lot of ways, type classes, they are a big part of ad hoc polymorphism, because when you're doing ad hoc polymorphism with just extension functions, you get to the point where you need context. You at some point, your function is going to need something else. And ideally, for me, you find that thing at compile time. The compiler finds it and fills it in for you. And I don't want to have to always be explicitly specifying all those parameters to the function. So you could do like a dependency injection thing and have a context, and and I haven't seen anybody do that with type class or with like extension functions in Kotlin to provide the necessary context. But I think at some point, when you do enough with extension functions, you realize, oh, okay, here's why I need type classes to make ad hoc polymorphism useful.
So is it typical that you have just a single type class as an argument for your function, or would it be reasonable to have multiple type classes?
I think
because it seems like you'd want to be able to vary in different directions.
So I think most of the places where I've seen type classes used, there's only a single parameter, like context parameter.
In Scala, you could have more than one implicit, right?
You can. Yeah. So there's definitely places where in my Scala classes I'll have multiple implicits, but in those cases I think so Play Framework has a way to do a dependency injection, and it's based on juice dependency injection. And I think that that's primarily the place where I have done multiple implicit parameters, is that I want to, in my dependency injection, make some of the parameters implicit when they get pulled in. And so what would be interesting is like, all right, I have used dependency injection in Play and used implicits. How much of that could be replaced by type classes, and how would that feel?
Because I could certainly imagine saying, well, here's this context for, I don't know, databases, and here's a context for spoken language, and and I would want those things to vary independently.
Right.
So it seems like using, having a function that could use multiple type classes would make sense, unless what it is just, oh, well, the type class is kind of like a configuration file.
Yeah.
And so you would only have one. But that would seem limiting to me, just the way I'm thinking.
Yeah. Yeah, I think
we'll need to have some examples in the
in our Scala 3 book.
Scala 3 book, yeah.
So one of the nice things about the way that like Spring does dependency injection is that when you get into these really complex graphs, it's pretty easy to override just one little piece of that graph. Whereas with type classes, it is more because it is explicit. I think you run into some complexity when, like, okay, a JSON parser type class maybe it needs a locale type class, but then maybe your locale type class needs some other type class. And like you can get into these complicated graphs where it's
Mm.
like, okay, if I want to override just this one piece of it, like what's the ergonomics of doing that? And I think that that's maybe where, so Zio doesn't use type classes. They have like more of like the cake pattern style. And so maybe that's where like type classes are great when you don't have a very complex graph that's needed, but then you need something like dependency injection when your graph gets large and unwieldy.
It just feels more, it feels like dependency injection leans more towards dynamic and type classes lean more towards static.
Yeah, yeah,
And so maybe there's, because yeah, now that you say it, I could see, oh, what if you use a type class that itself uses type classes? Oh, now that's getting, and it's kind of like generics where it has to work under all of those situations.
right. Well, and type classes, in most situations that I've seen type classes, they do use generics. So
I think that
generics
was one
are,
of our questions
yeah,
was, are the two separable, or are they inherently connected to each other?
yeah. I like you would never really use type classes if you only ever have one of a thing.
Sure.
And so you need more than one type. And so I think that you could do that through um, through generics, or you could also do it through inheritance
Mm-hmm.
or ADTs, the kind of new inheritance.
Algebraic data types.
Yeah,
Mm-hmm.
yeah, but I don't think you'd ever use type classes if there was only ever one concrete type for something.
What would be the point?
Yeah, then type.
It's about variation.
It's
It's
about
about,
overlap, right? And
yeah,
so
yeah. It's like, well, here's all this common code, and here are the different
yeah,
type classes we might want to plug into it
yeah,
to
yeah,
produce different behavior.
yeah. And so in the case of like a JSON parser, it's pretty cool because you can within type classes use type classes, and you can even use a type class can even use itself, so you can have like these like recursive type classes. So let's say you
But
have
that's all resolved at compile time.
all resolved at compile
Mm.
time. So let's say that you have a type class that what you need is a list of something, and you write the type class to be able to handle a list of some generic thing. Uh, and then so you're like combining ad hoc polymorphism with parametric polymorphism. But then what's really cool about this in type classes is that in that just by writing that type class that takes a list of something, you can then handle a list of that thing as well, because
Mm.
you've written the type class for a list of something. Well, it turns out a list of something is a list of something.
Sure.
So that's where you get into the recursive, that the type class can use itself to resolve
Mm.
the need that it has.
Mm.
So there's that part of type classes is pretty cool,
This
and it actually
is,
gets used a lot in like JSON parsers.
I'm wondering if, because C++ had developed this thing, it's a little rarefied. It's called template metaprogramming.
Huh.
And I don't know why, but it's kind of tickling my mind thinking, I wonder if template metaprogramming wasn't trying to do something similar to this, because it had that, you could have recursive template structures and things like that. And,
Yeah,
but
maybe
it was
there's a
beyond
similar
my
concept
ability
there.
to understand
Yeah.
at the time.
Huh. Yeah. I'll have to look at ZioJSON to see if ZioJSON uses type classes. I don't think it does. So I wonder how they deal with some of this. I'll have to look into that.
Mm-hmm. I find it's often very helpful to compare approaches, because it gives you insights on, oh, this is why we're doing it this way. Whereas if you just see it, I mean, like, for example, when I first encountered inheritance-based polymorphism in C++ through dynamic binding, it was just like, why are we doing this?
Yeah.
What is the design motivation behind this choice?
Yeah.
Well, and we were talking about Eclipse and how they had some design choices that they made, which made it at least unusable for me, because I wanted to make plugins for, and they say, oh, it's easy, and then it turned out that they had used these design patterns, because they had a design patterns guy from one of the Gang of Four was working on the Eclipse project, and I guess they go, well, we must have to use design patterns then. And it was just one bridge too far for me to want to. It was one of those things where I'm going, I'm sure that it is possible to do this, but right now I can't quite make it there. I had the same problem with there was a programming language that was supposed to be, it was designed to build expert systems. And I just couldn't get my brain to turn the corner to understand why it was designed this way. Yeah. And so I never understood the language.
Yeah. Yeah. Understanding the underlying motivations is helps to understand.
Well, I think it might be key, because I mean, I think this is our argument about why people don't understand monads is because, or what I was just, it's like, it's not presented from what problem are you trying to solve.
Yeah.
And there's this, the analogy that I was talking about with hash maps. Like, if you started talking about hash maps by saying, well, first you have to understand how to write a hash function and all the ins and outs for that, nobody would use hash maps, because it would just like, why am I doing this? It's too complex. But if you just say, it looks up values based on keys and don't worry about the other stuff until you run into problems, then it's like, oh, okay, I can use that.
Yeah. Yeah.
And I think we need to how do you present things in a way that people can grasp it or are motivated to grasp it? Yeah. Or is this just another cake pattern that you're giving me that is like, it seemed like a good idea, but without understanding it, the motivation behind it, I can't really grasp it.
Yeah. Yeah. It's interesting. It seems like a lot of times in technology, we're like building a bridge, and we think we see an island out in the distance that we're building a bridge to. And sometimes we keep building that bridge, and it turns out that island was just a mirage, or
it's not big enough to justify building a bridge to it.
Yeah. And when you get way out there, you've built the bridge for so long, you can't even see shore anymore, and you've forgotten like what you were even aiming for. Yeah.
Right. Yeah.
Yeah. So in the case of Eclipse, my understanding was that the whole foundational model, which was OSGI, was built on the idea that you could reload and install plugins into Eclipse without having to reload the IDE. And what was fascinating was that, 15 years after Eclipse was created, I went to install a plugin, and it's like, you must reload your IDE. And it's like, okay, like they clearly did not actually achieve what
their primary design
was
goal.
The primary design goal.
We built this whole thing around this.
Yeah.
And it turns out it was not a valuable choice, because it's like,
because who cares?
It's like, it's like when you
how often are you reinstalling plugin?
You upgrade your IntelliJ idea, and you have to restart it, and it's like, okay, fine,
no big deal.
The benefits outweigh the costs. And choosing your making sure that your design goal is really well. Look at Rust.
People care about.
They know what their design goal is no garbage collector. You in chapter 4 it says object ownership is what Rust is all about. And it's like, okay, that, and the payoff is significant, especially when performance is your key goal. Then not having a garbage collector is really useful. there's a cost, but they understood the cost,
Yeah.
and they said, "Yep, we're going to pay that cost. We're going to give you as much compiler support as possible, but this is our thing."
Yeah.
And they knew it and designed around it.
It's nice to be clear with your with the people that you hope will use your thing about what it is your design goals are.
Right, because with Eclipse, they, my impression was that the design goal was that this was going to be a plug-in centric uh, environment, and so
Everything is a plugin.
everything's a plug-in. And it's like, if I had known that it was going to be so hard to create a plugin, I mean, I don't know if I've seen like an editor where the plugins were um, that easy. I mean, I've used Sublime Text for a long time, and the plugins are written in Python, but you still have to. There's this whole plugin ecosystem that you have to understand, and I again never gotten that far. It got funky or something, but I never got far enough to go, okay, sure, I'll just write a plugin. I have written plugins for it, but it's like not at the
Yeah.
it's not effortless enough that I would just do it all the time. And to me, if I was developing something like that and I go, we're plugin centric, I would just go,
building
plugins is going to be, you're not even going to have to think about it, at least for a large class of plugins. Maybe there's some plugins where you'd have this trapdoor thing that you would drop through and you go, okay, now it's more complicated. But the baseline would be, this is effortless. You can.
I think VS Code has done that, and I think Atom before it was the plugin model, and Atom was so easy.
Okay.
There was some issues with how they did plugins, really around like their UI model for plugins. Anyways,
because
it ended up being bad, but I think that VS Code like took some inspiration from how well it was done in Atom, and how quickly the plugin ecosystem sprung up and how quickly it grew around Atom, and said, oh, we want that for VS Code.
Yeah. And I just started, I mean, I've been dipping my toes into VS Code, and I didn't use it because there were a couple of things. One of them was I wanted it for, using Sublime Text, I was using for a Markdown. And there was something, it was reformatting. It didn't have any way to reformat. VS Code didn't have any way to reformat Markdown, because it's easier for me to read it when it's formatted nicely. And I recently found out that somebody has made a Markdown reformatting plugin, and it's so much better. I mean, it's so smart about how it's doing it. And so it's like, I'm not using Sublime Text for that. I mean, I immediately have switched to VS Code. It's so much nicer for dealing with Markdown. And I started thinking, well, I wonder if their plugin ecosystem framework or whatever is going to be easy enough that I could write my own plugins. And you're telling me that I could.
Yeah.
So that's intriguing.
It's pretty, they've made it pretty trivial. And I think that that's for some things like UI frameworks, IDEs, what else would fall into this class? Like kind of dependency injection style, like frameworks, maybe just frameworks is the right classification. But one of the core design principles should be to enable the ecosystem. And I think that if you are building one of these things where having a healthy, large ecosystem is important, and hopefully is one of your core design goals, then I think that what you can do is you can look at your ecosystem and use it as a judge of the foundations that you've built. And this is where, like, back to the days of Flex, the component ecosystem around Flex was huge. Like, it blew up. jQuery, same thing. And I think that is kind of a way to judge your foundations and say, like, did we get the foundations right? And if you're not seeing this like rapid, amazing growth of an ecosystem around your thing, maybe your foundations are wrong.
Yeah, if people can't come to it and go, I think I could make one of these, and they do it and they put it out there. Well, the Python ecosystem is so huge because there's enough pieces in place. I mean, people still have issues about, yeah, this could be better, that could be better. But basically,
Massive ecosystem.
I go pip install thingy, use thingy, and when somebody writes a new thing, they can just put it out there, and it's basically easily installable. And that's an example of somebody who got it right.
Yep. Yeah, for sure. Well, and I'm sure that it came from really valuing, like you're saying. Like,
absolutely.
You have to really value that and make it a core principle.
Well, when Guido was creating it in the first place, it was like, I want to make this the programming language for everyone, so everyone can program.
Yeah,
that was his value, and I think he, focused around, and he built a whole community with that in mind. And so, now
I've seen UI component frameworks with like no third-party components, and it's like, okay, like
crickets.
Yeah, something foundational is wrong.
Mm-hmm. Yeah, I think it needs to be something that is like viral. Basically, it's like somebody looks at it and it's just immediately makes sense to them. It's solving all the problems, and yet when you dig down a little, you're still able to solve the harder problems. And that is a design challenge. Somebody's got, but when you see it, it. An example is command line tools in Python. People kept making them, and then finally this guy, I think it's the same one who came up with Flask, he said, "Oh, I'll make one," and he calls it Click. And I started using that, and I go, "Oh, this is what I've been looking for all this time." And it's a lot of, and when it works for you, you go, wow, there's the design thinking that went into this is really elegant. And also, I can't imagine how they did that. Their brains are much bigger than mine, that they could achieve this elegance of design.
You'd say it just clicked.
It did. Well, CLI, command line interface, Click, just the name works really well. Yeah. So.
Yeah, I think for people who are building frameworks, languages, IDEs, anything where the ecosystem is a huge part of the success of it, if they look around and they don't see a very strong, vibrant, growing ecosystem around their thing, I think the message is like, look at your foundations and look at your values, because you probably haven't gotten those correct.
Yes.
Zio just has exploded in terms of how the ecosystem that has grown up around it so quickly. And I think it's such a testament to them getting the right foundational pieces correct.
Yeah. And there's so much that goes into that. It's more, it feels cultural, because sometimes, like, I've encountered people who are trying to design new programming languages, and I look at the language and I go, "Oh, you're using semicolons. Do you really need to use semicolons?" And, their answer might be, "Well, man up and put the semicolons in there." I'm going, I don't know. This throws shade on the rest of your, this one decision makes me question everything about what you're trying to do.
Yeah.
And because, not having the new version of Scala doesn't have semicolons. Kotlin doesn't have it. Python, of course,
all Scala doesn't have semicolons.
Oh,
they're optional in Scala too?
Have they always been optional? Yeah. Oh, okay. Yeah. Why did I think that was different? I guess I don't know. But I mean, and it's like the compiler can figure it out. Why are you still making me put these dumb little things at the end of every line? And it's just,
well, I think it is back to the core value of, if you want to build an ecosystem, then you need to think very deeply about what your intended users want and
what their experience is going to be.
Yeah. And if you're building a programming language, it's very likely that your target users don't want to put semicolons in.
Yeah. Or I mean, or to say new.
Right.
You know, I mean, Java didn't have to put new in
Yeah.
because everything was being put on the heap anyway. So,
Yeah.
But they, yeah, all those things.
All those things.
All those things. It's, and we think it's about programming. We think it's about the languages and the pieces and everything, but it's actually more than that.
It's about the people.
It's about the people. It's it was the term that you kept using, you know, about the ergonomics.
Yeah.
It's about the ergonomics of the thing.
Well, what's interesting is that ergonomics is all about what the person needs, right?
And how they feel.
Yeah, and how they feel.
Right. You know,
Yeah.
it's like when you talk about the ergonomics of a chair, it's how does that chair feel? Yeah. And how does it affect your body? And, you know, long-term effects. Long-term effects of typing semicolons is carpal tunnel syndrome still a thing? I don't know. I feel like it kind of, yeah, I feel like it kind of fit. But anyway, it's like, no, the extra effort, and it's not just extra effort in terms of, you know, typing. It's like, well, you got to see all that. It adds extra noise to what you're looking at. It's just, and you can say, oh, well, it's subtle, ignore it. But when you say that to me, then I go, what else are you doing that I'm supposed to ignore?
Yeah.
That's actually making it harder for me to think about the problem I'm trying to solve.
Right. Yeah, and it may give you compiler tunnel syndrome.
Oh, we've invented a new term.
Yeah. All right. Okay. Well, polymorphism. It's all about
what the heck is it? It's like magnets. How do they work? Polymorphism. What is it?
It's better than copy and paste.
It is better than, I guess. Do we know that for sure?
Nope.
All right. So ends another episode of Happy Path Programming.